All right, so this is just a reminder about what we talked about on Friday. The inverse, let me not use yellow, inverse operation of an exponential expression is a logarithm. The inverse operation of a logarithmic expression is an exponential. Okay, important for us to remember, logs and exponentials are inverses of each other, just like addition and subtraction are inverses of each other. So to undo logs, we need exponentials. To undo exponentials, we need to do logs. Okay, so let's look. All right. I want us checking every one of these on Desmos. That's why I want you guys to have Desmos up. Please do not have Netflix and everything else up. If you have, I don't see you guys with your AirPods in right now. A few of you were the other day. If you have in your AirPods, take them out for now so that you make sure you're with me. That also makes me feel like you're not watching Netflix there while I'm trying to teach. So that would be ideal there. All right, so there are two ways to check your answers, and I want you guys to always check your answers on these because there will be a few where we get extraneous solutions, okay? Those extraneous solutions are solutions where we did everything right, but the answer doesn't work. So I'm going to stress to you using Desmos because the way that we're going to check on Desmos works for any equation. No matter what type of equation you are using, right? So it will work for anything, which is helpful when you get to that exam at the very end, and it's been since September, and it's now December, and you have not seen this in a long time. And I'd love to tell you we'll do a lot of good review, but we don't have a lot of time in this class. I don't know if we're going to get nearly as much as I'd like to have. So, this will work on any equation. And they give you Desmos on the exam, right? Even if it's crazy stuff we didn't even do in class. You could possibly still use this checking method and get the right answer, okay? The first way you can always check, we've taught you how to do this since you learned how to do equations, is plug your answer back in, right? So you can plug your answer in and see if it works. You can do that by hand there. The other way you can do this is put the left side of the equation into Desmos as f of x. Type the right side into that should say into. Desmos is g of x. See where the two functions intersect. X coordinate is your answer because you're solving for your x there. All right, so let's practice that here. Let's do the next question. And we're going to do these questions and we're going to solve. All right, so I'm going to do this by hand. Then we're going to type it into Desmos to check. All right, so what I see here is that I have got exponents right here. Why is it not letting me, right? I've got exponents right here, and in at least this exponent right here, I have a variable. I am trying to solve for that little x right there. I'm trying to get it all by itself. But that x, I can't get to it till I get rid of that 3. And that 3 is a base of an exponent. How do we get rid of a base of an exponent? Logs. So I'm going to do log base 3 on this side, and that big 3 is going to go away. Then I also have to do log base 3 on the other side. What's going to happen there? So what does this look kind of like what we had on the other side? Like I got log base 3 and I got a 3, right? And now here I've got log base 3 and I got a 3. These also cancel out, which actually means now I've just got 3x plus 3 equals 4. Okay? So if you have the same base on both sides, that base just cancels out on both sides, right? if you think about it, like if I've got 2 to the x equals 2 to the third, what does x have to equal? If this is like a super simple, like if I've got 2 to the x equals 2 to the third, what's the only number x could equal? It's got to be 3 for these two things to match, right? So that's what's happening here. You got this 3 to this power and 3 to this power. Since you got that same base, the exponents have to equal. Passion, how do I solve that equation? Very good. And that'll give me 1, and then what would I have to do? Divide by 3. Wonderful. X equals 1/3. Okay? Now, I want us checking everything on Desmos. So, every single one, because some of these don't work. If I put Desmos up here, and so to check on Desmos, you're going to say f of x equals, and then you're going to put in the left side of the equation, 3 to the 3x plus 3. It's going to graph something. It might look crazy. Who knows? Oh, that's bad. Is that what I was trying to type in? That plus 3 should be up in the exponent. I think you got to put parentheses around it to make it stay up there. Yeah, put some parentheses and it'll stay up there. And then I'm going to say g of x equals 3 to the 4th power. Okay, now here's my problem. What is 3 to the 4th power? It's 3 times 3 times 3 times 3, which is 9 times 9, which is 81. It's a big number, right? So these cross, I just can't see it. So if I zoom out enough, oh, there it is, right? And if I point there, we might want to zoom in on that point a little bit, because if you're not careful, it'll give you the y-intercept. I get 0.333, which is 1/3, right? So that was our answer. So I know that that's right. The y-coordinate we ignore for that, okay? All right. So let's do the next one. Oh, I didn't mean to close Desmos. Damn. Let's put that back over there. All right. So on this next one, I've got basically the same thing happening here. I've got a base of 3. What am I going to have to do to get rid of that base of 3 right there? We're going to do log base 3. And since I've got a base of 3 on both sides, it just cancels like it did on the last problem. So I've got negative 3k minus 2 equals negative 3k plus 2. All right. Carlos, how do I solve that? You need to add, and it doesn't matter which one you move. I'm going to move this one. Oh, no. Oh, that just makes it worse. This is bad well, it's bad on purpose. I wanted it to be here. The 3k's cancel on both sides. Since that happens, we're just left with negative 2 equals 2. Do I have a k to solve for anymore? No. Is negative 2 equal to 2? So what do I say whenever this happens? Close. It's a different expression. No solution. It's no solution. Yeah. Undefined is not a terrible answer there, though. You had the right idea. All right. Now, if I check this in Desmos, this is what, so if I do f of x equals 3 to the negative 3, oh, that was an e, not a 3. 3 to the negative 3k minus 2. And then I do, oh, don't use a k, use x. If you have a variable besides, g of x equals 3 to the negative 3x plus 2. All right, so if I look, they do look like they cross, but I don't get, if I click on them, I don't get any gray dots anywhere. And if I zoom in, I want you to look whenever I zoom in. They look like they touch right there, but look what happens. If I zoom in, oh, they're not touching, right? It's a horizontal asymptote, and that top graph is always just a little bit above. They're getting closer and closer to each other, but they never actually touch. So that confirms that this is no solution here. You can zoom out some maybe and try to like click on it. If they do cross, there should be a gray dot that shows up somewhere, and these do not. There, so that one would be no solution. All right, so let's try number 3. Drew, what are we going to have to do?
Cancel out the 5.
Okay, cancel out those 5s because we're going to do log base 5 on this side. Gets rid of it. Log base 5 on this side. We'll get rid of the base, and I'm just left with the exponents. 3n plus 3 equals 3n plus 3. Negative 3n plus 3 equals 3n plus 3. Let's see. Andrea, what would I have to do to solve that equation? Okay, I would add that 3n. It's best to move your variables first. And I like adding right there too because that keeps you from getting a negative, right? So I got 6n plus 3. What would come next, Andrea? Subtract 3. What is 3 minus 3? 0. That feels wrong, but it's okay. That's correct. Divide by 6. Divide by 6. What's 0 divided by 6? 0 is your n. All right. If we graph to check over here, if I do f of x equals 5 to the negative 3x plus 3, and g of x equals 5 to the 3x plus 3. I can see those, hold on. Alright, they don't look like they cross, do they? But maybe they do. Zoom way out. Oh, okay. See how see the difference here in the last problem? I zoomed out, and whenever I zoom out enough and I click, there is a gray dot showing me that they do cross. So, they cross there. The x is 0 for that. So, all right. Questions there? All right. Here's our next ones. Okay. You've already solved ones like number 4. Okay? You already did it. You just did it before. If I want to get rid, I need to solve for this n right here. It is in the exponents, which means I got to get rid of the 11. That is not 11 times n. I cannot divide by 11. How do I get rid of that 11? Log. Okay? It is the base of an exponent, so I'm going to do log base 11 to get rid of it, which means I got to do log base 11 on the other side. So n equals log base 11 of 44. To type that in, I should have just kept the split screen. To type that in on Desmos, let's see, let me write that back. N equals log base 11 of 44. To type that in on Desmos, because I want, now, before I was just having you rewrite, I do want the actual answer. If you are using Desmos, you can go down here and, gosh, you got to go all the way to functions, and it's going to be down here somewhere. Log with that little base, and you're going to tell it 11 of 44. Oops. Put that in the parentheses there. And so I'm getting 1.5781. I think your worksheet today is going to tell you to round to 4 decimal places. 1.5781. Okay. I would rather just use my handheld calculator for this. How do I type that in these? Yeah, log 44 divided by log 11. I just think it's faster to type it in because you don't have to go any. You can also do that in Desmos. Log 44 divided by log 11, and it'll give you the answer there too. I prefer doing that because you don't have to go to the menu on that, but you can do it either way that you prefer. Okay? All right. Everybody good there? All right. Oops. Okay. All right. So, try 5. See what you get. I'm gonna hide my screen so you can't see what I'm doing. Try 5. And especially on these exponentials, most of your answers are going to be decimals. All right, check with your neighbors, see what they got, or if they've got it yet.
I can do it backwards. Me. Well, so you put 110 up 100. You put 15 or 100?
100.
Unfair.
Yeah. Yeah. The base always goes on the bottom. All right. Here's your answer. See if you got it right. 1.7005.
Log 100.
Make sure you close your parentheses, then divide.
Okay, so on my calculator, I put log with parentheses 50 divided by log with parentheses.
100 goes on top. The base goes on the bottom. Yeah. Yeah. When you type it in, you got to do the 100 on top. The base goes on the bottom. Remember that little number is called the base. Base is always on the bottom of something, right? Yes. Did you type it in like this? Log 100 divided by log 40, log 15. Yeah, no, you didn't do that. What did you do wrong? Did you see it? Log 100, close parentheses, divided by log 15. Okay, yeah. Yours is multiplying, that makes sense. Okay? All right, we okay here? All right. Okay. All right. 6 is going to be a little harder. Okay, but it's not impossible. Okay? It's not even, I'm going to say, I don't even think it's all that difficult. Not that bad, maybe. I don't know, math teachers. I might not should say that. Right? All right. We're trying to solve for K. It's way up here. Now, that whole thing right there is the exponent. I can't get to the exponent till I get rid of that 2, but I got something else over here. I got that 1. The 1 is even further away than the 2, right? When we're solving equations, we want to start with whatever is furthest away. So I've got to get rid of the 1 first. I need to add that 1. Okay? So that's going to get rid of the 1. 2k minus 4 equals 9. Alright? So again, still I've got to get up there to that exponent. I'm trying to get to the exponent. To get to that exponent, I got to get rid of that 2. Got to do log base 2. That'll get rid of this over here. I've just got k minus 4 equals, and then this is log base 2 of 9, but let's just go ahead and get a decimal for that. So let's grab our calculators here. What goes on top? Log 9 divided by log 2, 3.1699. So 3.1699. All right, that K is almost by itself now, just about. What's my last step? Add that 4. So K is going to be 7.1699. That's not that bad, right? It's not nearly as scary as it looks. Okay?
So basically when we're doing those, we do, okay. So we're doing only one thing that changes and there's just like a whole exact thing.
It's really like just like solving equations has been the whole time, except for you got this new thing that you can use like a log to get rid of that exponent. Okay. Oh, I said we were going to check these on Desmos. Let's type it in real quick and check. If I want to check this on Desmos, or if I forget how to do it, because we're going to have a quiz at the end of class tomorrow. We're going to practice first, and then we're going to have a quiz. If I forget how to do it, and I'm desperate, and I have no idea what I'm doing, I can type in f of x equals 2 to the k minus, or x minus 4, use the x, don't put the k, and then I'll do minus 1 into f of x. G of x is just going to equal the other side, that's 8. I will look at where they cross. They cross at 7.17. It doesn't give you enough decimal places, which might be a problem typing it in, but 7.1699 is equal to 7.17 if it's just rounded a little bit shorter, okay? So, and I think probably on the quiz I'll do 3 decimal places. Our worksheet today says 4, and our practice says 4, but just because of Desmos, I might make it 3 on the, because Desmos rounds to 3 there. So, if you were to forget, like, let's pretend that maybe we forgot how to solve number 7, and we didn't know. We'll do it by hand here in a second, because I want you to be able to do it by hand. But let's say we're not sure, okay? We could do 14 to the 10x minus 3 plus 7. Put the whole, everything on this side of the equal sign goes here. It equals 72. We put it here. Now, at first it's going to look like you don't have anything that crosses, but x equals 72 right here. So let me zoom way on out. There we go. They cross out. I probably need to zoom in a little closer right there because it's so close to the y-axis. Make sure I'm getting the right number. 0.458 is going to be my answer. Okay, so I want you to be able to do these by hand, but if you're desperate, this works every time for every equation. Sometimes it's hard to find it on the graph is really the biggest issue. But all right, but let's do it by hand. We can do this by hand. All right, let's see. Sailor, what do you think I should do first on that problem? Yes, perfect. Subtract 7. That is going to be 14 to the 10m minus 3 equals 65. All right. Okay, Ayla, what have I got to do next? We're going to log it. What's the base on that log? 14. All right, that'll get rid of the 14 over here. I just have 10m minus 3. Over here, I've got log base 14 of 65, but I would really prefer not to have to see that log anymore, and it's just numbers, so I can just type it into the calculator, right? So, log, what do we got? Log 65 divided by log 14. Oops, I didn't hit the log. Hello? I haven't even looked. I think is it linked to the end of the week? Let me check real quick. Hold on, guys. Yeah. It's at the very top of the events of the week. Very top. Yeah. Very top. All right, we're going to continue logging in here. They didn't pick yours. Don't know why. All right, see you. Bye. Coach Wood needed some brief assistance. Sorry about that. Okay. All right. All right. So we got 10. Oh, no. Hold on. We got 10m minus 3 equals, what was that decimal? 5, 8, 1, 4, 7. Okay. What have we got to do? Add 3. 10 m equals 4.5817. Divide by 10. M is going to equal 0.4817, which is what we got whenever we just typed it into Desmos, right? Or 45817. Sorry about that. Okay. As far as on your paper, it is always fine with me if you keep extra decimal places. I don't care. So if you leave your answer like this, it's okay. Now, whenever if I give you a quiz on Canvas, and our quiz will be on Canvas, it is a little pickier. It will not take any more than 4 decimal places. So, huh?
Can we do less than 4?
I will put it on there, but usually I'll put round your answer to 3 decimal places so that you know what to round to on that. All right. Okay. Those were exponential equations. We must also be able to solve some log equations. Okay. Also, these are not all that bad. This is one of Coach Wood's favorite. I should have told him we were getting ready to do this. This is one of his favorite subjects to teach. You have missed out on not having Coach Wood for this because it's one of his favorites. So, for 8, I've got a LN, so that's a natural log. What's the base on an LN? E. It's an E. If it's just a log, just a plain log, it's 10. But this is an E. So I'm going to write an N just to remind me. So to get rid of it, I just do E to the power on both sides. But because there's a natural log on both sides, it just makes them go away on both sides, right? Coach Wood's favorite thing to call this is dropping the logs.
Drop the log!
He has something written all over his face. So, his favorite thing to call this is dropping the logs, as you have seen here. And sometimes he puts poop emojis on his slides here to remind you to drop the logs, if you need that reference there. So, this only works if log's on both sides of the equation, right? Log has to be on both sides of the equation. So, 5k minus 7 equals k plus 9. Aiden, how would I solve that? You will run into fewer problems if you try to do the variables first. If you try to move variables first, because where I've got a k on both sides, I got to put those together. So yeah, so well, you can't just put them together because we got to move it to the other side. So I would subtract this k right here. It's like a 1k, right? You could move the 7. You would need to add it if you did. But this will give you 4k minus 7 equals 9. I have found that students run into fewer problems if they move their variables first, then deal with the other numbers. Okay? And then, so after I do that, now, Aiden, what would come next? Now I would add the 7. So 4k would equal 16. And what would be the last step, Aiden? Good. And I will get k equals 4. Alright. You can plug it back in. Actually, oh, yeah. Yeah. Alright, I want you to use Desmos to check on these because sometimes you run into some issues with these. So, using Desmos to check here. F of x equals natural log of 5x minus 7. G of x equals natural log of x plus 9. Let's hit the house button so we can see it. And right there, 4 is our x coordinate. Okay? Sometimes you run into issues with these, so we just need to be careful. I don't know if this one does or not. I can't remember. All right, now whenever you see a problem like number 9, you got logs, you got the same base on both sides. If you don't have the same base, just go to Desmos and do the problem. We don't know how to do those without the same basis. You're not going. I don't think you'll see it, but who knows what they may put on the exam. 6 to the power, 6 to the power. Drop the logs. Minus x minus 10 equals 4x minus 5. William, what should I do to solve that? Okay, let's move our x's first. Which one do we want to move, the negative x or the 4x? You can do either one, but I kind of like doing this so that I don't end up with negatives, right? So I got negative 10 equals 5x minus 5. Then what would we do next, William? Add the 5. Add the 5. All right, so I get negative 5 equals 5x. Divide by 5. Divide by 5. Negative 1 is my answer. Now, I want you to check on Desmos for all of these. I feel nervous about this one because I feel like there's going to be an issue. Yeah, it doesn't, sometimes negatives work, but they don't always. I feel a little bit more nervous. To get to log with a base of 6, you're going to hit functions. It's down here towards the bottom, right here, underneath calculus. I don't know why they put it underneath calculus, because logs show up in other places, but and then g of x equals, you can copy and paste in this. I'm going to do that so I don't have to go back. And then I can just change this inside part. 4x minus 5. Now here is the issue. I don't see, oh, there's my green graph. Oh, does this look like they're going to cross? Ooh. It does not. Okay, so what has happened here is we did everything right when we solved that equation. But if we were to plug in our answer to check, I would have log base 6 of negative 1 minus 10. All right, and that would be log base 6. That negative would become a positive, but I'd still have 1 minus 10, which would give me negative 9. If I try to do in my calculator log of negative 9 divided by log of 6, it gives me an error. If I try it in Desmos, it's going to do the same thing. If I try to type in log negative 9 divided by, oh, see, right there, there's the problem. I could divide it by a log of 6. It's still something. It's going to tell me undefined. You cannot take a log of a negative number. And so that is the reason that although you get an answer, it doesn't actually work. And that is one of the main reasons that I'm telling you that you need to check your answers on all these. So, so this one is actually no solution. It does not happen all that often, but it does happen. Like I think on your homework, you've got at least 1, maybe 2, where you get no solution for your answer. Okay. I want you guys to have plenty of time to work on this worksheet, so I'm going to skip 10 so we can get to these couple others. We might not even do all those. That way you can do some practice on your own. All right, so let's look at 11. For 11, I don't see a base. I'm trying to solve for this b right here, but I can't get to it because of the log. It has a base of 10. How do I get rid of that log? 10 to the power, 10 to the power, b equals 10 to the negative 2. I don't know if you guys have done negative exponents. It's 0.01, but we need to rely on the calculator for that right now. That's fine. I think we got to do something with them later. We get 0.01 or 1 over 100. So b equals 0.01. It would be good to plug that in and check it. I'm not going to right now because I want us to get to these other problems. Okay. All right, let's see. Ooh. Let's see. Let's look at, I'm going to skip down here to 13 because I've got lots of problems here. We don't necessarily need to do all of them. So for 13, Easton, I need to solve for that P, but it's on the inside of a log, so what am I going to have to do? How could I get rid of that log? Okay. Opposite, or the inverse of logs are exponential, so I'm going to take that base of the log and do 3 to the power. It's going to get rid of it over here, which means I'm doing 3 to the power over here. So I got P plus 4 equals 3 to the second. You can do it on your calculator, but what is 3 squared? 9. All right. And then, Easton, what do I have to do after that? Subtract that 4. P just equals 5. For the sake of time, I'm going to tell you that that one's okay. You don't need to plug it. If you plug in 5 plus 4, you get 9. It's positive. It's okay for that. 14 is very similar. I'm going to skip it too. All right. Oh, let's look at 15. We're going to do 15, then we're going to do 18. Ooh, if you can do 18, you can do any of them, right? All right. So for 15. My M is here on the inside of the log. I need to get rid of that log, but there's something else I got to get rid of first. That -7. How am I going to get rid of it? It feels like I should add it, but it is not. It is right beside of that log. It means it's multiplied. We need to divide by -7. So log base 9 of M minus 6 is going to equal 1. Now, over here, I'm not going to do 16, but on 16, how would I get rid of that -8? I would add it because the it is separated by that plus sign. See the difference between 15 and 16? Okay, now I think I'm safe to get rid of the log. Elijah, what would I need to do to get rid of that log? Okay, opposite 9 to the power of, but I think that's probably what you meant, right? So we got M minus 6 is going to equal 9 to the first power. But what is 9 to the first power? It's just 9. All right. And then let's see. Anissa, what would I do last? Perfect. Add that 6. M equals 15. And again, for the sake of time, I'm going to tell you that answer is fine. It works. But you could type it into Desmos. All right, let's do 18. If we can do 18, we can do any of these problems. It's got everything in it. First of all, well, let's just start. Okay, Shay, what do you feel like we should do first here? All right, so when you're solving equations, n is what we're trying to get by itself, right? N is way over here. In general, you want to start furthest away from the n, which means I'm trying to get rid of this -10. How do I get rid of that -10? Perfect. Add 10. Okay, so now I have 4 log of 6 minus 3n equals 16. Okay, so when you're solving, start furthest away from your variable. Try to get rid of whatever you see there. So now, next furthest away is 4. And what did I do, William? Divide it. Very good. It feels like maybe I should subtract, but it's right beside that log, so I got to divide. So log of 6 minus 3n equals 4. Oh, I need to get rid of that log, but it doesn't have a base. There's a 10 right there. We can't see it, but there's a 10 right there. Katie, what would I do to get rid of that log? Okay, we cancel it out with a, what number do we use? A 10 raised up to that power, right? So we'll do that on this side. We'll also do that on this side. Now, some of these problems you end up with some pretty big numbers. because 10 to the 4th, when you type that into your calculator, is 1 with 4 zeros. So our answer is going to be kind of big here. But it's okay. That might happen on some of these. All right. Okay, Katie, what would be next? Perfect. Subtract that 6. So now we got negative 3n equals 9,994. Yep. All right, and last thing, Katie. Divide by that negative 3. And so whenever we do that, somebody do that in your calculator for me. Is it a decimal?
Yes.
It's negative
0.3 repeating. Yeah, that's fine. You probably just didn't type negative in. We should divide by negative 3 right there. So we'll get a negative. Okay? All right. Is it as scary as the problems look? Do you feel like maybe you can do this? I hope. I feel like you guys can do this.
I feel like this will be easier than this.
I think you can do it. I think that logs are scary. I like teaching logs because I think they're scary but easy once you finally get into it. So I hope that you guys feel the same way. So, and if you don't, ask me questions as you're working. Okay? All right. Okay. All right. So here is your worksheet. She might have been wrong. I think that 5 right there should have been a 1. Oh, sorry. I thought Katie did that. She did the problem. You told me. I think it should be a 1.
It should be a 1.
Oh wait, I do need to show you just the very last example. I need to show you one thing.
What did you type in? What? No, you subtract the 6. You subtract it.
Okay. All right.
You subtract the 6. It was a positive. You subtract it.
All right. I didn't put any of these on the worksheet. I think you'll be okay. All right.
The heart of those.
There are 2 more that I did not give you. You guys see something like this? Like number 19? We don't know how to do that by hand because you have different bases on each side. And you can't do like a log 9 over here and a log 81 over here. You can't do that. If you do a log 9 to one side, you got to do log 9 to the other side also. So if you